Hey guys, we saw in the last video that the difference between the definitions of satisfiable set and satisfiable formula. Also, we have another definitions, which is a validity, valid formula. And I'll denote this validity of a formula. We can have the next definition of validity of the formula. We can say that if the formula A is valid, then, and this is really important, A is the logical consequence of the empty set. And that's it. Do not write more. This is the complete definition, and the teacher will put that as a good answer. Once again, what is validity of a formula? If the formula A is valid, then A is a logical consequence of the empty set. And remember this part, that we put the results is valid when every part of the formula is true. And we don't have in the final part any zero, like this. Here we have a true here, true here, true here, but we have a false here. That means it's not valid, but is satisfiable, because we have at least 3 true, even though there is 1 0. Don't worry about it, just put that is satisfiable. So please make sure that you have the difference between which is validity and which is something satisfiable. Let's do one extra exercise of this. I will say that prove that the formula P implies Q and P implies negation Q. All of this is satisfiable. Okay, so once again, it's proof, and the second word is satisfiable. So we know that this is satisfiable. We just want to prove it. So let's make a truth table, P, Q. Then we can say that P implies Q, and also we can check it out with the truth table. The P implies negation Q. This must be satisfiable. So we have 0, 1, 0, 1, 0, 0, 1, 1. P implies Q. The only chance is when this is 1 and ends in 0. It will be 0. Otherwise, it will be 1. And negation Q, that's negated, 1, 0, 1, 0. And P will be 0, 0, 1, 1. The implication will be here is 0 and otherwise is 1. So this is our final part. We have something interesting here and here. That means we have a model, because it's true. Here is true and here is true. Okay, so we have a model. Here is true and here is true. Yes, we have a model. Here is 0 and here is 1, and no model. So that's not good. And here we have the same situation, no model. So not good. That means it's satisfiable, because these two rows, we have two models, so is satisfiable. But remember, it's not valid, okay? Because here we have a discrepancy. We have 0 and 1, and here we have 1 and 0. So it's not valid. It's just satisfiable, and we prove it. Okay, let's check it out. Another definition, important definition, logical consequences. Logical consequence. The definitions short as soon as possible. A is the logical consequence of gamma if gamma union the singleton negation A is unsatisfiable. And please, just answer this, no more. If your answer have more words, maybe the teacher can ask that is something wrong. So just ask this. What exercise it could be good for this definition? Okay, for this definition, logical consequence, I can imagine the next, that P implies Q, then P implies negation Q is the logical consequence of negation negation P, I'm sorry. This is P, it's not Q. Negation P, I'm so sorry. Okay, we have this. The first part that you must do in your test is make a set. So we're going to put the set, we're going to contradicting this part. We're going to make unsatisfiable the set. So we say that the same, P implies Q, this is going to be the same, comma, P implies negation Q is also the same, but here we're going to contradict in the set. So negation P, this is going to be unsatisfiable. That is really important, is the most important part. And then we can do the truth table to prove it. P and Q, because we don't have more elements. This P and Q, we can do the truth table 0, 1, 0, 1, 0, 0, 1, 1, and then the rest of the formulas. P implies Q, then P implies negation Q, and negation P. The negation P is going to be the same, 0, 0, 1, 1. I don't need to give you the more information because it's just contradicting this. But the double negation, it will be the same as P. So we have this first line, then the negation Q, it will be 1, 0, 1, 0. The P, it will be 0, 0, 1, 1. And in this final answer, the only chance that is going to be 0 is here. 0, then we have 1, then we have 1 and 1. And here we have P implies Q. P implies Q is going to be here 1, 1, 0, 1. So let's check our final answers. Let's check the first row. Here's 1 and here's 1, but here's 0, so no model. No model. That is not good. We have 1, 1, and we have 1, 0 here. No model. No model. Okay. Here is 0, 1, 1, no model. And here is 1, 0, 1, no model. So it's unsatisfiable and is not valid. So that means this is for n satisfiable. So we have a correct, a logical consequence, I'm sorry. We have a logical consequence of this. Negation P is a logical consequence of these two formulas. Okay, so thank you for watching this video.